Good day again. We are now on our second performance task requirement, particularly on the topic on the measurement of area and volume. Rather, volume and capacity. First, we are advised to familiarize first the measures of area, considering the table provided here. Again, we need ratios in order to convert unit area from one unit to another. As we discussed, talking about metric unit, we are considering metric fixes, and this time we modify the idea of using metric converter. So always refer to the table provided. For the measure of an area, it follows also that the fundamental unit of area in metric system is a square meter. A square meter. Continue. Okay, so we'll discuss a little about metric converter. In a measurement of length, we always consider the numbers of movement from the original unit to convert it to other unit. Like for example, here, if you are required to convert 9.5 square meters to square millimeters. Again, using metric converter, you have to count how many times you move from meter to millimeters. So notice that we are moving 3 times to the left. So again, it will affect also the movement of points. From the given, which is 9.5. So since we are talking about area, the 3 times movement will be multiplied by 2. And 2 times 3 is 6. That means to say that you are going to move the decimal point 6 times to the left of the given number. In this case, we are moving from 9.5 6 times to the left, so we are adding around 5 zeros, so that the corresponding value of the millimeter squared in the given is equivalent to 9,500,000 millimeters squared. Take an example. To convert 600 or 6,500,000 square meters to hectometers. Notice from the metric converter, we are moving 2 times to the right. Since hectometer is greater than meter, so 2 times to the right, multiply by 2. Now, why is it that we are always multiplying it by 2? Since we are talking about area, it seems that we are respecting the way that we are doubling the number as we get the area. Multiplying the two intersecting measures, the vertical and the horizontal, or the length and the width. So we always multiply the unit or the unit of length 2 times by itself. In that case, we consider that That is why we have a constant value of 2. Talking about area, always multiply by 2 by the movements of the original unit to we converted to the next unit. In this case, 2 multiplied by 2, you have 4. So that means to say that if the given is 600, 6,500,000 meters squared, we are moving from the point 4 times to the right side. So, right side, meaning to say we go back from 0, count 4 times, so we end up at 650. Meaning to say that the corresponding value of 6,500,000 is equivalent to 650 feet 2 meters squared. I hope you get that idea. Next, okay, we are now on the application set 2.1.1. Just follow the outline provided for you to be guided for the presentation of your output to be passed next week. Now, in number 1, if the side of a square is 3 centimeters, find the area in terms of millimeters squared, centimeters squared, and decimeters squared. Tapos, why is it that, you might surprise, why is it that there is provided graphing area or graphing calibrations provided there? Aside from considering the metric converter, also you can use graphing paper in counting exactly how many areas you are dealing with. If it is 3 by 3 centimeters, for every calibration, if you assign that is, assuming that it is 3 centimeters, just count 3 times horizontally and another 3 times vertically. And whatever is the coverage of that area, just count how many squares of the graphing paper would be included in the area of the measure given. If it's 3 by 3, so mean to say that you are multiplying 3 times 3, that is equivalent to 9 areas. 9 by 9. Oh no, 3 areas. I think we need to discuss this later during our class before you answer the problem, so that it will be explained clearly what you're going to do with this activity. So, also you can use metric converter in this case class. Number, or the second set of the activity is what happened to, okay, the second set is problem solving. Okay, what is the length of the small scale division if we divided 1 meter line into 10 equal centimeter unit parts? Okay, you can analyze this. You can use meter stick or simply make calibration just to represent to how many times you divide 1 meter unit into a centimeter. Number 2, refer to, we will correct that. Refer to the first question. Connect a small scale division to form how many squares? Okay. Number 3, how many square meters are in 1 hectare? And number 4, for the second set, express the measure of 120 square meters or meters squared in terms of centimeters squared using metric converter. So the last set of the performance task in this particular topic is, okay, number 1, a newly married couple, it's a problem solving. Newly married couple wants to buy a lot of 15,000 square meters. How many hectares of land are the couple buying? Number 2, how many gallons of paint are needed to cover 25 air surface? If a quart of paint can cover 10 square meter surface. I think that would be the last activity for the measure of area. Now let's now continue for